Electron affinity. As you can see the word here affinity, this word affinity means attraction. As we know, everything in this universe wants to get stable, and same is the case for this atom. This atom also wants to get stable, and now this atom wants to gain another electron in order to get stable. We know that there is a positive charge inside the nucleus because nucleus just have protons and neutrons. Protons have positive charge and neutrons have no charge. That is why the overall charge on the nucleus is positive. This positive charge is attracting all the negative charges here. It means if any electron comes around this atom will for sure attract that electron also towards itself. Now what happens that when this nucleus attract the electron towards itself, it gains the electrons and gets a negative charge as a whole, and when it gains the electrons, as a result this atom needs to pay a price, and this atom pays the price as a form of energy. Let's understand this concept with the help of an example. Here we have a person and the person is very hungry. Thus, the person is unstable. Now, what this person will do? This person will buy some fruit from this fruit cart. Now, this person will definitely pay some price in order to get that fruit, and as a result, this person will get stable. Same happens with these atoms, that these atoms attract another electron. They gains the electron, all these atoms need to pay a price, and as a result they lose some energy. The certain amount of energy that these atoms loses is called as the electron affinity. What is the electron affinity? Electron affinity is defined as the amount of energy released when an electron adds up in the valence shell of an isolated atom to form a uni-negative gaseous ion. Now what is this uni-negative gaseous ion here? It means a negative charge. A whole negative charge will be there on the atom, because when an atom gains an electron, ultimately the whole atom gets a negative charge. Why always we need an isolated atom? Because it's very clear, if we are going to talk about a bonded atom, the bonded atom is already stable. Why this bonded atom will attract another electron? This bonded atom is not interested to gain another electron. Energy is supplied for removing an electron implies that energy will be released if an extra electron is added to the atom. Here we have some factors governing electron affinity. The greater the nuclear charge, more will be the electron affinity, because increase in nuclear change increase nuclear force on the valence electrons. Every atom has a nucleus. Now if the charge of the nucleus is greater, then what does that mean? It means that the nucleus will attract this electron more strongly because it has more positive charge. So more positive charge means more attraction of the nucleus for these electrons. It means more electron affinity. Nuclear charge is directly proportional to electron affinity. If we have more nuclear charge, it means we have more electron affinity. And if there is less nuclear charge, it means less electron affinity. If the atomic size is small, then there will be greater electron affinity because the effective nuclear charge forces will be greater in the smaller atoms and the electrons will be held firmly. Now here we are discussing atomic radius. Here we have an atom and this atom has a smaller radius, and on the other side we have another atom and this atom has comparatively a larger size. Now what will happen that the attraction of this atom towards the electron will be more as compared to the attraction of this atom towards the electron, just because of the atomic radius. Small atomic radius means more attraction. More atomic radius means less attraction. Shielding or screening effect is inversely proportional to the electron affinity. Now, if we have a nucleus here, we have first shell here, second shell here, third shell here. In all these shells, we have some electrons. Now, because this nucleus is attracting all these electrons here, and these electrons which are present here inside the shells are also shielding the nuclear attraction, so the electron which is outside will face less nuclear attraction just because of this shielding electrons. So as a result, the electron affinity will be lesser. So more shielding effect, it means less electron affinity. Now here is a very important question, that either the electron affinity is endothermic or exothermic. Here we can understand this with the help of this example of oxygen atom. We know that oxygen gets stable by gaining two electrons. Now, at first, isolated gaseous atom of oxygen will attract an electron. This oxygen atom will gain an electron. It will release the energy in the form of electron affinity. When it will release the energy, it means this reaction is exothermic reaction. Now, this atom is having a negative charge. We all know that oxygen needs an other electron in order to get stable, but this time this atom has a negative charge and electron also has a negative charge. Negative and negative, these both charges will repel each other. When there is a repulsion between these two charges, then how come this atom can gain an electron? Is this possible? No, this is something now nearly impossible. Now, this time, what will happen, that we need to give some more energy to this atom to gain the electron. When we are giving the energy, it means this is endothermic reaction. In the first step, when this oxygen atom gains one electron, it's the exothermic reaction. In the second step, when this oxygen atom and gains an other electron, it's the endothermic reaction. Now it's very clear, if there's an atom and that atom needs two or more electrons in order to get stable, whenever the atom will gain the first electron, the first step will be exothermic, and whenever the atom try to gain an other electron in order to get stable, the second or third step will be endothermic. Now we have trends for electron affinity in the periodic table. Electron affinity across the period. As we move left to right in the periodic table, what usually happens, that the nuclear charge increases. Now what does that mean? Nuclear charge increase means more number of protons. More number of protons means more attraction towards the electron. More attraction towards the electrons means more electron affinity. So it's very clear, when we move left to right across the period, electron affinity will increase due to the increase in the nuclear charge. Electron affinity down the group. When we move from top to bottom in the periodic table, shielding effect increases because number of electron increases. When the shielding effect increases, it means that the shielding electron increases and the strength and power of this nucleus to attract the electron will be lesser as a result. When it will be lesser, it means this time the electron affinity is also lesser. As we move from top to bottom in the periodic table, what happens? Shielding effect increases, and as a result, electron affinity decreases. So yes, this is all about our today's lecture. If you want more such videos, please don't forget to subscribe. Thank you very much.